Hey y'all, this is OXDF, and today for the Business CTF 2023, we're going to be looking at a couple of the forensics challenges from the 2022 Business CTF. The first one of them is MB Coin. It's a challenge I actually got to create. It was a fun one to make and hopefully a fun one to solve. It's a real piece of malware, a real phishing doc, and it's a Word document that has some lightly obfuscated Visual Basic for applications like macros in there, and it drops a VB script, which then downloads a handful of DLLs or tries to. Now, if you run that, it's not going to actually download them because the URLs it connects to don't exist. But we also get a PCAP with the challenge, and we can go through the PCAP and carve out the requests that were made, figure out how to take the data that was sent back in those requests, decode it, and get the flag out of a .NET executable that comes back. The second one we're going to look at is called Perseverance, and this is a really neat challenge. It's a WMI persistence challenge. We're going to give you the WMI repository from a Windows machine, and with the idea that there's something malicious going on in there. And so we're going to have to do a little bit of background to learn about what exactly is WMI at a very surface level, because WMI is very complicated. Specifically, we're going to look at WMI events and how they're set up in the three parts of a WMI event. And then we're going to use some Python scripts from the Flare team over that originally put out the famous talk about WMI persistence in 2015. And we're going to use those scripts to first carve out the filters that are causing us problems. And then we're going to have to go back in and get the default value for a WMI object that the persistence is using. And from there, we will get an actual piece of, a binary that would be a grunt or a C2. And in there, in a decryption key, we will find a flag. So it's a fun time. Let's go ahead and dive in. MB Coin. This is actually a challenge I wrote, and it's based on a real phishing doc. I made some changes at the end, and of course, instead of downloading malware, it downloads a little binary that gives you a flag. But otherwise, it's a real piece of malware. So it's a realistic challenge. Let's take a look and see what we can find. The prompt is, we've actively been monitoring the most extensive spear phishing campaign in recent history for the last 2 months. It abuses crypto market crash to target disappointed crypto owners. We've detected it, and we've got some malicious email as well as some network traffic assessed to be associated with the user who opened the document. Let's find out what happened. So I'm starting here in a Windows VM. We will jump over here, and I've got the document here. We'll go ahead and give it an open. As super common, right? Anything downloaded from the internet, you're going to have this macros have been disabled. That's a hint that there's probably some macros to check out. Let's see. Have you been wondering how to make money? Get through now. You may be eligible for thing. Make sure you click enable contents. That's a very common thing you see in phishing documents, is they're telling you, oh yeah, skip through that security thing and go ahead and just enable it, and we'll calculate how much MB coin you've won. We can actually enable this. We'll live a little dangerously here. We know this is not, it's from Hack the Box. It's not actually going to hurt my system. So here we go. Unfortunately, I am not eligible for free coin, and that is a bummer. But it did pop up and tell me that. So let's take a look and see what we have here. I can hit Alt F11 to jump up into the macro editor. Apologies to anyone who does not like light mode like myself, but the Microsoft application here does not give me many options that I know of. And this is simple, so we won't be here too long. Oh, and we're getting this pop-up. I'm going to come back to that in just a second. Well, we'll do it right quick. There's a problem starting program data www.dll. And so we can actually quick break here and jump over and go to program data, and there's no www.dll. That's probably part of the problem. We could dig into these files, what's legit, what was there not. We could also take a snap, like delete them all and then take a snap, but it might mess up my system. But we could look at like what changes when we run this, but we won't need to. It's gonna become very obvious real quick here. So we've got these two objects. Let's see, we've QQ. So first of all, this runs auto open, so it's going to run when the document opens. We've got QQ1 and QQ2, which are reading off active document shapes. I can grab that right here and come down to like the intermediate window and do print document shapes. Oh, I cannot do that. Oh, I can't. Of course not. Let's see, I can grab it like this. If I do set like this, and then we can get QQ alternative text. That's what I'm looking for. So we can do print, and we can see it looks like the contents of a script of some kind here, starting here. So we can pull that information, but I'm jumping ahead of myself here a little bit. So we got these two objects which are being used to hide text in the document. They could even be like the monkey logos we saw in the document. I think that's what I did. And then we've got some strings here. So we've got C program data, pin.vbs. We're doing a lot of string reversing here. Here's some more stuff. I'm not sure where that gets used. We are getting, I'm clearly changing the document when I'm dragging it around. We are getting the alternative text from these two objects, and we're saving it as dub. And then we're going to create a file. We're going to open ROI, which we can see here is RO, so program data nip pin.vbs, and we're going to write to it. And then we're going to get a shell, and we're going to call. This is going to be reversed, but we don't need to type this out. cmd/k cscript.exe, and then we're going to call that script. Then we're going to wait about 5 seconds, and then we are going to say, no matter what, you're not eligible for coin. No one was ever going to get the coin, guys. It's kind of disappointing. So we're basically going to run this script, and we're done with the macro part here, so we can skip out of this. Let's close that. We're basically done with the document. So we can go into, let's see, we already did. The fastest way to do this is I will open up a new file explorer and go to program data. And here is pin.vbs. We'll open it with Notepad++, and here we go. I'm going to pause real quick here and just show how we could have done the same thing from Linux. If we had been over here, I've got the same stuff in a document here. OLE VBA, my favorite tool for getting macros out of documents. We can run this and, oops, better page up here. We can see the same macro here that is dumped here. It's warning us about the different suspicious things it's doing, so that's pretty nice. We need a way to get those strings out. OLE dump is another tool from DA Stevens that's super useful. We can run that here, and it will show us the different streams that are available in the OLE object. And in fact, we could take, so it looks like vast majority of these are all associated with macros. We've got this Word document one, and we've got this one table one. I don't know exactly which one it is, but we can do, if we pick a stream, so let's pick like stream 15, the Word document, and we do a -D, it's going to print all that stuff to the screen. Now that one was not super useful and seems to have maybe even broken my terminal. What was the other one we had? 4 was kind of long. And I'm just picking the longer ones because they're the more likely to have this kind of stuff in them, right? And boom, there we go. Here is the, oops, I went past it. Here is the different strings we need. So it's a little harder because we don't have exactly where they start and end, but we could basically get a feel for, what these two big strings we need to grab and how to put them in order. So we could do that from this Linux machine as well. And from here on, we could do basically everything from the Linux machine as well. I'm just going to do it over here because I've got a whole copy in the Windows VM. So let's take a look at this script. First of all, it's going to do this kind of date add thing until now. So this is probably the long sleep that we saw that caused some issues before I saw that error pop up. Then we've got these LL things. I'm just going to pretend we're going to skip those for a second and see how they're useful. We'll come back to them. Now I'm building this H0, which is just the string PowerShell combined this way. I'm going to create a WScript shell. Now I'm going to run PowerShell space and then each of the LL things, comma 0. So I'm going to use the WScript shell to run each of these PowerShell things. I'm going to sleep for 5 seconds. Now I've got these things, so some more obfuscated PowerShell. And I'm doing the same thing. So I'm running the PowerShell for each of those, sleeping half a second in between each of them. And at the end, here I got to sleep for 15 seconds. And then I'm going to run DLL32, so run a DLL on this www.dll in program data, calling the ordinal or the export LDR. So DLL's export functions, and we want to find the LDR function. Then we're going to clean up after ourselves, sleep some more. What is OK1, OK2, OK3? I didn't even see those. And then we run some stuff that doesn't exist. So it might even just be left over. Oh no, right here. Sorry. We're setting those things and then we're doing those things. So yeah. So what are these things up here? Let's take a look. I'm going to grab one of these. We will just, I guess we'll just jump to a new file here. We lose our syntax highlighting. Maybe we'll just do it in another line here. We can keep syntax highlighting. Okay, we'll do it this way. So nano is equal to jux replace joo with I. So this is the string IEX. Then we're going to set an alias OY to be nano, so be IEX. Now we have this AA is equal to new. We can basically start to piece this together, right? Because we can see AA, Q. We're going to join foox is equal to aaqqwwee, etc. So we're going to have new object, net web client, download file, URL. So basically, we're going to download this URL. We're going to save it to C program data www1.dll. We can see all these are actually the same, except for we have different URLs. So we have privacy careers, perfect demos, business Z, blah, blah, blah. And we have www1, www2, all the way through 5. So we're just going to download 5 different things and save them as www1 through 5. If we come down here to the next section, we got some more PowerShell here. And so we're going to do things like, and this is where, we can do that manually the way we just did, or we can start to do things where we, grab, let's see. So we have b equals read all bytes, blah, 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 through this line. We could just copy this, paste it in, and can't do, let's see, could not find. So we see what it's trying to do. Let's see, we'll come here and we'll say, let's not do all the actual read all bytes. Let's just grab this string. Let's see, maybe I've got one too many, but I think I need one. I need one here. Sweet. So you can see this is just building the string C program data www1.dll. So we're going to read all the bytes into B. K is going to be this string here, just adding together strings. R is going to be a new object that is a byte array of length of B. So the same length as B. And then we're going to do for I equals 0. I is less than b.length, I plus plus. We're going to go over each byte in B or I, B or R. R sub I is going to be B sub I XORed by the kth byte. Basically we're just applying an XOR string to this thing we downloaded. And then if r.length is greater than 0, so if b.length is greater than 0, we're going to write all the bytes into C. We can just basically say this is C program data www.dll to write the bytes. So what these lines are doing is we're going to take each of these DLLs, we're going to loop over them and decrypt them with a, I think, is it the same or is it different? It looks like it's actually changing slightly. Yes, there's definitely slight changes. Like here's OM1 plus X and OM1 plus P. So it kind of a custom XOR key for each one we download. And then we're writing all of them over www.dll. So that means whichever one runs, well, so that's what the 5Ms are. And we can see they all run in order. So whichever one runs last, like MM5 is going to be the one that is going to be the one we actually end up running as www or www.dll, assuming that succeeds. So what do we need out of here? If we try to run this now, clearly it failed because none of these URLs exist. They're all .hdb domains. They're not even real. So this is where we can use the PCAP. Let's go ahead real quick and take a look at the PCAP. And we can start off real quick. We see a bunch of DNS, which is, I'm going to skip through kind of an overview of the PCAP. We can jump straight to the DNS for the sake of time. We can see all these dots, like here's calling point.hackthebox, and we get back an IP. Here's another one with an IP. So let's see, what was the number 5 is corporate bonus.corporate business machines. So that's right here. And the response is no such name bonus. So that one didn't exist. That's not going to have returned anything. So that one won't have succeeded. This next one is cabling point.htb. And I'm going from the bottom because I want the one that was run last. So cabling point. That one did get a valid URL. So we kind of can say that's probably, let's take a look at what the streams here. This PCAP is quite short. There's not a lot in here. I'm going to grab a TCP packet towards the top and follow it. In fact, oh man, that's tiny. I wonder if I can make that bigger. We're not going to stay in this window very long. So all we need to really see here is that this one is to cabling point. It's actually the one we care about. And there's just a bunch of data here. The next stream is to businessz.htb, and there's a 404 not found. So that one isn't returning anything. And then there's one other privacy careers.htb, and that did return some stuff as well. So I'm most interested in, let's see, we'll export the objects. We'll grab the HTTP objects. We'll grab the cabling point.htb. That's the one we're interested in, and save it. And it's going to save it as vmm.html. So that's fine for now. And we'll close that, and we can actually get out of here. We've got this thing now, and we need to decode it. We need to do the decryption. So we can actually just grab, where's my M4? We just need this line right here, right? So we can do between the quotes. I'll do this. Let's see. First, let's grab where's our PowerShell here. So we'll go into desktop, biz, mbcoin. Okay, we got the thing here. We will copy vm.html to program data when this was www4.dll. And now I think I can just paste in literally all of that. And should be able to in our program data now. Did I have, I think I have that open somewhere here. Now I have a www.dll. And we can actually just run it. How are we running it? We want the LDR function, so we could grab this right here, copy. I lost my paste somehow. We'll just do, let's see, program data. So run DLL32, www.dll, comma LDR, and boom, we got the flag. This binary literally just pops up the message box with the flag. If you were to open it up and reverse it, it is a .NET binary, so you can get the full source, and it literally just calls this. We can even run strings on it in our Linux VM, and the flag will pop out there too. So a bunch of different ways to approach this problem. But anyway, this is a phishing document. It's a real phishing document, but also you're probably going to see a phishing document in this year's CTF, so keep an eye out for it. All right, next we're going to look at perseverance. Let's go ahead and check out the prompt. During a recent security assessment, the employees' credentials were in a data database. They basically come down to, I'm just kind of skim through this, but basically they've determined that there is a malicious actor living in their WMI for persistence. I've given the WMI repository from the user's workstation, and can I analyze and expose the technique? And this is super cool. I love WMI is such a cool thing. It's such a, and I still remember in 2015 when, in fact, we'll talk about this. I'm going to jump in here. There was this DEF CON presentation at DEF CON 23 by the FireEye team, and they just kind of like brought this out into the world in a way that was very exciting to watch. I really recommend, this is if you're in information security, this is an hour and 45 minutes well spent. It's information that's still useful to know today, even though it's 8 years old. I'm actually going to we're going to do a little WMI background here real quick, and I'm going to use slides out of that presentation. So basically, WMI is this incredibly complicated architecture where you have these different clients, there's query languages, there's this protocol standard called through DCOM, which can then talk to the WMI service, WMI management, which then has these providers, and there's a repository for database, and it can do things like create processes, and it can listen for events, and it can do all sorts of things. It's complicated. We are going to focus, and when we start thinking about malware living in WMI, we're going to focus largely on this thing called WMI events. And what that really is it's 3 pieces of WMI, a filter, a consumer, and a binding. And so a filter is a thing that says when this happens, this thing to watch out for. When this happens, this is what is going to cause me to trigger. A consumer is some action you're going to take. So you can say run a process, or write a log, or copy a file, or send a log somewhere. And so the binding is what registers and connects the filter to the consumer, so that when the filter happens, the binding points it to the consumer, and the consumer does the thing. And so this is really useful from the point of view of a piece of malware, because we can use this WMI filter, events to get persistence without keeping files on the disk, right? We're living in this WMI sim repository, in these managed objects, and we're not somewhere that you just see malware living on a system. So it's especially at the time was a very stealthy way to do things. So let's jump over here. We've got all these files except for prompt.txt are what came in the downloadable zip, and they told us in the zip that this is a WMI management repository. So the script we're going to use is this from the Flare team, which is let's see, go back up here. Oops, didn't mean to go that far. Which is from Flare WMI. Now this is old. It's like 6 or 7 years. Last modified 5 years ago. It says that the PySim is still actively developed. I don't know about that, but it works well, and it's certainly a good enough tool for what we're trying to do today. If you're at all familiar with the Impacket set of tools on Windows, which is on Linux, which is a set of Python libraries that do things that are that speak the Windows native things, and you get sample scripts with it. This is of the same idea. So there's this Python sim library, and we're going to pip install, we're going to go into this directory and run pip install dot to install this setup.py. But then there's also this samples directory with all these scripts that show us things you might want to do. So the same way that Impacket has a thing for Kerber roasting, that shows off. It's an example of using their tools. This has ways to show filter to consumer bindings, and so that's one of the scripts we're going to use. So we're going to use those samples. In fact, let's go over here and we'll do just that. We can do Python opt. Where did I store it? Flare WMI Python sim, and then we want to go to samples. And what did I just say? It's called show filters, maybe? Yeah. And just from playing around with this, we could open up the script and look. But we know this either has to take XP or Win7 as the first argument, and we're just going to assume it's Win7 because it's not XP. And we're going to give it the current directory to have the repository. And we actually get 2 bindings back here. You can see one here and one here. It's not the prettiest output, but it, okay. This first one is a SCM event log filter. This thing's legit Windows. This is like on all systems. I actually remember working in a large SOC and trying to implement rules to detect filter to consumer bindings, WMI filters across our enterprise, and being overwhelmed with the number of these type of events that I ran into that like, oh, these are legit, this is real. But this other one is not. And in fact, we can see, so here's our filter. It's called Windows Update, and it's a WMI query language. We're going to be searching for things when things get modified within WMI. I'm not exactly sure what this is doing, but it probably is going to end up being like a periodic thing that just happens every 60 seconds or so. But what's really interesting to me, obviously, is this payload, right? So we're going to run PowerShell with an encoded command right here. And so now seems like a good time to take this. In fact, we can just, let's say we go to CyberChef, but we can actually just do it right here. And we'll base 64 minus D to see what we get. One long line, let's tr replace semicolon with new line so we can get a kind of a better feel of what we're looking at. It's not bad. Okay, so file is going to be a WMI class. This in the root sim_v2 repository, we're looking for a WMI or Win32 memory array device object, and we're going to get the properties, the value. Then we're going to create a stream. We're going to take a file and convert it from base64, and then we're going to decompress it, deflate it with the deflate stream, and then we're basically going to load this into memory and invoke it. So we're going to pull a binary out of WIM and run it in memory without writing to disk. So the next thing we need to do then is figure out, okay, well, how do we figure out what this WMI memory array device is? And we'll use another, let's see, go up here. We'll use another one of these sample files, and we'll look, it's one's called autocarve class. We'll start with names. We can just give it the current directory again. And you can see these are all the class names that are defined and described within the WMI repository. Now, if we go to the very end, we see the last one, or the last two, is the one we're looking for here. So we can now do, instead of doing class names, we'll do class definitions. And this puts out a ton of output, so I'm going to just pipe it to less so we can search in it easily. And if I search for the memory array device, here it is. And so here is that device, and here's the default value, which is a big blob of base64 data. Which is exactly what I want, right? So let's, I'm going to shrink this window down to here so we can grab the whole thing. We'll come up here, copy that. Let's jump over and we can jump into CyberChef. Like whenever I have to do like inflates, that's always a useful one to do here. And I'll show you another trick we can do here. We'll paste in here. We're going to from base64. We're going to inflate, raw inflate. And hopefully, yep, we've got a Windows executable down here. MZ cannot be run in DOS mode. That's perfect. I want to take a look at this. Let's see. So we could save this to a file, and we'll call it like perseverance. I don't know how to spell it. .exe. And we will come here and move downloads perseverance.exe to here. We can do a file on perseverance.exe, and we can see that it's a Windows 32-bit executable. It's a .NET assembly, which means that we should be able to get the source code back or something very close to the source code. So that'll be neat. I could do this in ILSpy on this machine. Because I have a Windows VM available to me, I like DNSpy better, so I'm going to jump over to DNSpy. One trick we can do here, if we want to just grab this URL, copy this, come over here to my Windows VM, CyberShip. I don't even need to go to CyberShip. I'll just paste this in, and I get the exact same thing back here. So now I can download this, and I'll call it perseverance. Perseverance, isn't it? Perseverance.exe. And you are all here for the spelling lessons, I'm sure. We will open that here. We will open up dn spy. Drag this in. And the grunt stages. This is looking like a C, like actually probably a real C2. If we click in here, let's see what we get. So we've got some base 64 strings, got some more base 64 strings. Doing some decryption, it looks like. So maybe now we'll start taking a look at what some of these things are. Anytime I see a bunch of base 64 strings like this, I feel like I definitely want to at least take a look at what that means, what's going on there. So we can do a new tab. Put this in here. I thought I copied, paste. Oh yeah, okay. From base 64. That's definitely the start of a flag. So let's go ahead and grab this string builder right here. Oops, it's not me to do that. Back. This string builder right here, you can see we've got these 1, 2, 3, 4, and then it's actually used down here to create the key that's going to be used for encryption. So this is probably a legit piece of malware that we are just using the encryption key to be the flag. So let's paste this in here. And looks like we are getting very close. Hopefully, with any luck, this will produce the end. So not a super difficult challenge, especially the hardest part was probably finding the WMI tools to how to parse the WMI repository. And these Flare tools work really well for it, or Flare tools work really well for it. So I recommend those. Yeah, just understanding the idea of filter, consumer, and binding. And when you think about WMI, it's going to be really useful for you. So thanks for hanging out with me today. I'll talk to you next time.